Hello everyone, so I'm solving this question on this topic of indices where we have been given this equation over here, and then we know that if you plot ln y, which is on the y-axis, against x, so x goes on the y-axis, then you get a gradient which is 0.239. Now notice that I've drawn this line over here which has a positive gradient, so it inclines this way. If it was negative, then it would go the opposite way. Now, what I kind of have to do is, using this information, I have to find a. So first of all, I just write this equation over here. Then what I do is I try to make this equation into ln y by ln x. So what I'll do is I will just add ln on both sides of the equation. So here I go and I add ln y. ln y, that equals to ln 3a to the power of 2a multiplied by ax. So let me talk about some of the log rules. So if log of a product is being applied, you can actually break this down into log of a plus log of b. So this works for ln and logs of any other base likewise. So what I've done over here is I've taken this 3 multiplied by ax and I've kind of broken this down. So ln of these two multiplied, once you break it down, this becomes, so ln 3 plus ln of a to the power of x. So this is how I've kind of broken this down. Now I'll apply one more rule over here. So if you have ln or log of a number and their power is b, so that becomes a mathematical identity. If we move this b over here, and then this becomes b ln a, so that is another log rule. So I'll just use these two log rules and then I'll somehow modify this expression of mine. So ln 3 becomes 2a multiplied by ln 3. So this 2a, it comes right in front over here. Now ln 3 is just multiplied by 2a instead of 2a coming as a power of 3. Similarly, x comes and it gets multiplied right in front of ln a over here. Now I get my equation this way. They said that they're plotting ln y on the y-axis and x on the x-axis. So I'll just turn this equation into y is equals to mx plus c, the popular form that everyone knows. So ln y becomes y, and they want x as x. So this ln a, this becomes m, and then our c is 2a ln 3, this becomes the y-intercept. So our gradient over here is going to be m, which is ln a, and they've already provided the gradient in the question. They've said it's 0.239. Now m or ln a is equals to 0.239. Now what I'll do is I'll just solve this expression over here, this equation over here, then I'll find the value of a. Now what is ln? Ln is basically log e to the power of a. Now once I open it up, e to the power of 0.239 becomes 1.26, and now another important thing, this says that this is rounded to 3 significant figures. Now I kind of need to round it down to 3 significant figures, so my answer is going to be 1.27. Now part B of the question says that you have to find the value of x when the value of y is given. And if I go back into my equation over here, there are 3 unknowns, a, y, and x. Now a has been found out in part A, so now I'll just plug in the values of y and x. Now let me just write this equation. Y is equals to 3a, 3 to the power of 2a multiplied by a to the power of x. Now let me just write this equation over here. So our main equation was y is equal to 2a, a to the power of x, and in part A we kind of tweaked it until we got this into the form of y is equals to mx plus c. So I'm just going to rewrite this form over here because that's the easiest to work with. Now I have ln y, so the value of y is 36. I put ln 36 is equals to 2a. I just insert the value of a, which is 1.27, multiplied by ln 3. Now then I just make the subject of the equation equal to x. So I just switch the equation around. I just bring this term on the other side and then I divide by ln a, and so I get the value of x.